The difficulty with the traditional approach of looking at two-dimensional arrays as matrices is that it kind of glosses over a more fundamental understanding of how the data is organized. As an example of dimensionality, we can think about geometry. A zero-dimensional object would be a point. One dimension would be a continuum of points, or a line, and two dimensions, of course, is a series of lines, which is a plane. If we're working with discrete elements or variables in computer science, zero dimensions remains the same, just one data point. We'll use integers for simplicity's sake. A one-dimensional array is a series of points, which we've come to understand as a list. I'm going to represent this as a set using curly braces. Try and think of the entirety of the braces as a single object, the array, with smaller objects, the individual data points inside of it, kind of like a filing drawer filled with papers. A two-dimensional array is a set of points, or a filing cabinet with more than one drawer in it. Now, before we get into the nitty-gritty naming and numbering business, let's try and look at the context around this first, to help make sense of the abstractness of the numbers. Let's say that we're trying to keep track of the test grades of each student in a class. There are S total students and T total number of tests. Since each of the S students will take all T tests, there's going to be a total of S times T grades. We can start writing this out to see what the patterns are. Alice comes first alphabetically, and these are her grades, her test 0, test 1, and so on and so forth. Next comes Bob, his test 0, test 1, test 2, and then would be the next student, and so on. Once it's all filled out, this table will wind up being S rows by T columns. Now, keep your eye on this particular score right here, which we can name Bob's test 2 for now. Now, we don't want to have to name all of these variables. There's a lot of data points, so we're going to use arrays. Alice's test 0 and Alice's tests 1, and so on, can become Alice bracket 0 and Alice bracket 1. Similarly, Bob's test 0 and test 1 become Bob bracket 0, Bob bracket 1. And this continues down the line, so that Bob test 2 is now Bob bracket 2. Think about the entire top row, all of Alice's tests, as being a single object, her drawer. The next row is Bob's, with all of his tests inside of it. What we can do is close these drawers to get a better look at what's going on. What we have is another set, another list of things. It's a group of drawers in this case. Since we don't need individual names for each of these arrays, we can just name the entire filing cabinet. We're going to call this collection grades. Alice gets renamed to drawer 0, Bob becomes drawer 1, and so on and so forth. And if we want to refer to them, we just use brackets and then the student's number. The test we're going to be looking at, Bob bracket 2, has now just been renamed to grades bracket 1 bracket 2 because it's in drawer 1 of the grades cabinet and it's the second test. What this drawer and paper scheme more or less simplifies to is the standard matrix row column system. If you represent all the data as a table, the coordinates inside the brackets correspond to the row first, counting down from the top, and then the column number next. So let's use this 2D array of grades to do some simple calculations to see some examples of code. The first problem I want to look at is calculating a student's average test grade over all of their tests taken. In the cabinet, we would need to average every test paper inside a single student's drawer, and in the matrix, we need to average the contents of a single row. Now, the particular student's ID that we are trying to average is going to be stored in the parameter ID. What do we need to do to find their average? First, we look in the cabinet called grades, drawer number equal to their ID number, and grab test 0. Next, we need to do the same drawer ID and grab test 1 and add it. Grab test 2, add it in, so on and so forth. After we're finished finding the total, we can divide the sum by the number of tests to get the average score and return it. Now, this isn't too bad. In order to code this, we have to remember what the sum is, so we can create a variable to do that, which has to start at a sum of 0 before anything's added. To add a grade to the sum, we will use plus equals. To specify which grade out of the entire collection, we look in the cabinet, called grades, then use the bracket ID for the correct drawer number, and then brackets 0 for the first test, the 0th test, really. The next instruction is the same, with the test number changing, but not the ID number. As a result, we need a variable to represent the test number, And this goes in the second bracket. We're staying on the same row, but changing which column. The for loop, which changes this variable, will start at 0, the leftmost test. The final test will be equal to the number of tests in the drawer ID minus 1. Remember, we want the length of the drawer, not the length of the cabinet. Grades.length would tell us how many drawers there are, because grades is the name of the cabinet. So we use grades bracket ID dot length to tell us how many tests there are in a drawer. This is what dictates the end of our for loop. Now we divide the sum by the number of tests, and we have an average. Go ahead and pause here to look at the code if you need to. For a second example, let's say that we want to know the class average grade on the final exam. This would mean the average of the rightmost column, or the last element of each row. As we're computing an average again, we'll need a sum equal to 0 at the start, and we want to add row 0's last test, then row 1's last test, then row 2's last test, and so on. So we have to go to the cabinet, open drawer 0, and look at the last spot. Grades bracket 0 goes to the correct row. Bracket grades bracket 0 dot length minus 1 goes to the very last position of 0 row. We're going to do the same thing for the row number 1, and then do the same thing for row number 2. Notice how the row number is changing. So we're going to replace this number that's changing with a variable. Now we want a for loop to change this variable, starting at row 0, and then going to the last row. Now the last row is related to how many drawers there are in the cabinet, so that's just grades length. Now we can divide the sum by the number of students, which is, again, grades length, to get the average. For the last example, let's try and find the average grade for the entire class, so the average of every single number in the entire 2D array. What we want to do is to sum up all the papers in row 0, then all the papers in row 1, and so on. But in order to sum up all the papers in row 0, we have to add together row 0, column 0, row 0, column 1, and row 0, column 2, and so on. Then we repeat this process for each other row. To code this, we should start with the most specific instruction and look for the pattern. It looks like the row number is staying the same, while the column number is changing from 0 through the end of the row. So instead of repeating this, we use it once and loop it with the variable where the changing number used to be. Now these lines of code together represent the idea of summing a row. What we want to do is sum multiple rows, so we want to repeat this code, but on the next row number, and then the next one, and so on. So the row number is now a new variable, and it will be looped from 0 through the end of the rows. These loops together will cover the entire array and give us our grand total. The average will be the sum divided by the number of elements in the array, which in this case is the product of the number of rows and columns. These are probably the three situations you'll encounter the most often, using a single row or a single column, or using the whole array. 2D arrays are extremely useful tools, and hopefully this has helped you get a better understanding of how to handle them in your programs.